Hello everyone, so today we will see a problem on a flux in electrostatics. The problem is as follows. Consider an electric field E bar is equal to E naught x cap, where E naught is a constant and x cap is a unit vector in the x direction. Okay. The flux through the shaded area due to this field is. Okay, so we have to find the flux passing through this yellowish shaded area. Now this yellowish shaded area is parallelogram. You can see it has four corners on 0, 0, 0, 0A0, AAA, and A0A. This A0A point is in XZ plane. This is Y axis, X axis, and Z axis. So this point is in XZ plane, and this AAA is in somewhere middle at a distance, at the same distance from X, Y, and Z axis. So the surface is nothing but tilted towards this XY plane, and it has a base on the Y axis. So for example, from this point, if I draw a perpendicular on XY axis, then this distance is A, is denoted by, this is also A, and this is also A. So shadow of this surface area, this area is nothing but a square on the XY axis. So this is how we have visualized our surface. So this was given in the problem. Now what we have to find the flux through this area. Also please note that the electric field, which is denoted by this, which is represented by this pink lines, pink arrows, is constant everywhere. Its magnitude is constant, only its direction, the field is in x direction. And we know what is the formula for x. Formula for x is E bar dot ds bar. Now since E bar is constant in magnitude and the integration over ds bar is nothing but the total area of this shaded region, so we will get E bar dot S bar. Okay, and why the area is represented in terms of vector, why there is bar? So the unit vector for area vector is in the direction perpendicular to the surface. Okay, so if I simplify it will nothing but be E S cos theta, where theta is the angle between electric field vector and area vector. Okay, so if I draw this perpendicular, uh, so angle between this vector and this vector, since we can see whatever the angle between this area vector with the x-axis, same will be this angle. Okay, same will be this angle since it is perpendicular to the surface. Okay, so we just have to find what is the theta. We can drop a perpendicular, we have shown over here. This is also theta. Since this is a parallelogram, this theta is also equal to this theta, and we have dropped the perpendicular. Why we are dropping the perpendicular over here? To calculate what is theta, since we know this distance is a. What is this distance? This is nothing but the hypotenuse for our triangle. What is this distance? This distance is nothing but, what is the distance formula? We will use the distance formula to calculate the distance. Let me just label this as A, this as B. So what is the distance AB? It is nothing but, so the formula is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, everything inside a square root. Here x2 is A, y2 is A, and z2 is A. x1 is 0, y1 is A, and z1 is 0. So I will have A minus 0 square plus A minus A whole square, again A minus 0 whole square. So it will be nothing but A square plus A square. So 2A square, this is 0. So it is nothing but root 2A. So this size is root 2A. This is A. And we know we can use our sine cosine formulae, sine cos tan formulae to calculate the angle theta. Here I have adjacent side to this angle theta and the hypotenuse. That means if I write cos theta as adjacent upon hypotenuse, I will have a upon root 2a, which is nothing but 1 upon root 2. For acute angle, this implies theta is equal to 45 degree. Okay, so for our formula for flux, we will have flux is equal to E S cos 45, which is 1 upon root 2. So 1 upon root 2 E S. To find out this area of the shaded region, S. Now if you look closely, the shaded region is nothing but a rectangle. This parallelogram looking figure is nothing but a rectangle because it's in 3D. It looks like a parallelogram from our angle, but it is actually rectangle. It could be verified using a dot product formula. For example, if you take a dot product of this side vector with this side vector, then dot product will be 0. Okay, so we know this is 90 degree, and since it is a parallelogram, we know the parallelogram with 90 degree angle is nothing but a rectangle. So one of the sides of this rectangle is root 2a, and other side, which is height, is a. So total area of this is root 2a square, this shaded area. So flux nothing but 1 upon root 2. And please note that this uh, magnitude of this E bar is E naught, and its direction is taken care of with this cos theta. So this E is nothing but E naught. So E root 1 upon root 2 E naught root 2 A square. Root 2 will get cancelled, and we will have E naught A square, the flux passing through this surface area. So this is the answer. We can see because of the tilt of this rectangle, the amount of flux is not maximum. Otherwise, what would be the amount of flux had this rectangle been in YZ plane? You know, if rectangle was in this YZ plane, then the flux would be perpendicular, or flux would be parallel to the area vector of the surface. It will be perpendicular to surface, but parallel to the area vector. At that time, the maximum flux would have been passing through that area, and in that case, the it will be simply be E naught, or it will be E bar dot S bar, and that cos theta will be 1 in that case. So it will be ES or E naught, and S will be nothing but the total area of rectangle root 2 A square. So this is the maximum flux that could pass through this area. And what is the minimum flux? To calculate the minimum flux, we will just put down this rectangle in XY plane, so that the electric lines which will not cross this area, since this will be in XY plane like this, and electric lines are like this. Okay, parallel to surface or perpendicular to the area vector. Therefore, that cos theta will be 0, and the minimum amount of flux. So this is maximum flux. Minimum flux is 0. The minimum flux that could pass through is 0. And in our case, this theta was 45 degree. Therefore, we obtained this flux. Okay. So as we tilt this area towards XY axis, towards XY plane, this plane, the flux will decrease, and as we move up this area, the flux will increase. Thanks for watching this video. I'll see you in next video.